Hello, it's me, and what I'd like to do is I'd like to go through some demonstrations of some of the puzzles that I've unboxed. Because the process of discovering a solution to them, even if you don't have the puzzle like this, exactly what it is that leads to the process of how to figure out how to solve a new puzzle. That's what's kind of exciting about these. There's really no tutorials, there's really no guidance out there to really see how to solve this, so it's all based on commutators that can be designed from this. So when looking at this puzzle, the question is, what's my approach going to be? Well, I see that there's two basic structures to this. This is the Star of David. Basically it moves through the center like so. And then in addition, so we move this way, we move this way, and we move this way. But we also move these tips over here. So when analyzing a puzzle like this, what's the best way to go about figuring out how to solve this? So what I'm going to do actually is I'm going to go through various puzzles that I've unboxed and just kind of show you my approach on how to do that. Well, something that I notice is that the scramble of these centers here are pretty limited. In other words, they don't really scramble much. They just pivot. They just rotate back and forth. So that shouldn't be difficult. Then it's a matter of getting these guys in. The technique of putting these in is going to take a little bit of doing because we slice through the center and the edges. And the question is, how am I going to get the corners back in? So looking at this, what kind of an algorithm can I generate to see if I can move these guys around? Well, the algorithms that I generate, I don't like to be much different than what I've already used. Now this is an 180-degree puzzle, so if I turn it here, I can't turn it over here. Now, granted, that makes the discovery of algorithms a little bit more difficult, because to have to do 180-degree turns means that I have to keep track of more things, basically. When trying to generate algorithms, looking at the structure of the puzzle, if it's a structure like, say, this guy over here, which is a skew, then it becomes a down, down, up, up, and then variations of that. If it's something that moves in 90 degrees in all directions like a cube, then it's something like RU, RIUI. When you're dealing with generation of commutators of puzzles that turn 180 degrees, then you have to do variations of 2R, U, 2R, UI, 2R. So 2R, U, 2R, UI, 2R. Then I look around and I see what movements can be isolated. Okay, so bear that in mind. Anytime I come across a puzzle that only moves by way of 180 degrees, then I'm going to be doing variations of 2RU, 2RUI, 2R in terms of generating algorithms. So why don't I just go ahead and scramble this and see what I can do. But before I do that, let's do an algorithm that's a classic corner swap and see how this guides me with this puzzle here. So 2RU, 2RUI, 2R, and then to get the structure back, I'll go UI, DI. This is basically just a corner swap. Let's see what it does. 2R, UI, 2R, U, 2R. This gets swapped back. So nice to know that this did not get changed at all. I can swap, I can rotate this back here as well. What's also nice to know is these edges, notice, did not change. So as I look around here, I see that this corner didn't change, but these three did. So basically this is a 3-cycle of corners. Instead of doing a corner swap, which is what that algorithm is, apparently this went to here, this went to here, and the one that was here went to here. So basically now I have a way of rotating these corners around, not affecting these guys. So why don't I just now throw caution to the wind, because now I have a fairly confident, comfortable way of moving this puzzle around, or moving the corners around, and seeing what happens with this. So I'm trying to separate all these corners. Now, something else to notice about this puzzle, which is going to help assist in the solve of this, is as I'm scrambling this, there is a limitation on how I can scramble. And something to notice is this, and this all scramble with each other, but they don't scramble with these guys. So in true star formation, these this triangle here, these only scramble with each other, and these only scramble with each other. So I'm going to potentially bear that in mind when it comes to the solve. Okay, so I think that's pretty good. Very unique puzzle. I don't think I've encountered anything quite like this. So what I like about it is I like the look of the scramble. I like how it has a very interesting, nice, colorful pattern. I like a puzzle that you can really tell when it's scrambled up. Makes it look more impressive as you solve it. So how am I going to approach this? What I'm going to do is I'm going to get all of these guys in first, and because these are fairly easy, they only scramble by doing 180-degree turns. If the screen isn't here, it's probably down here. So I'm just going to turn this in, more or less just orienting myself here. Turn this in, and turn this here, turn this here. Okay, turn this over here too. So there's a kind of an intuitive way of doing this. So this is in, these two corners are in, this is in, and this is in. So this is really much like a floppy puzzle right now. But instead of a four-sided floppy puzzle, it's a 1, 2, 3, 4, 5, 6. Six-sided floppy puzzle. So now I want to put this corner type piece in. When I solve this top part, I'll automatically solve this bottom part here as well. So I'm looking for the green and beige. Green and beige is over here. So I want to move this guy to here, but coordinate it with this center over here, if I can. So the way to do that is, why don't I bump this out of the way, like so. Move this down, then put this back in, which coordinates it with this guy, and move this back up to here. Alright, so fairly quickly we're able to get this back in. I would imagine that perhaps it can be harder than that, but only insofar as you have to do some more rotating around. But anyway, we're fairly easily able to get this over here. I suspect these are going to be the more challenging parts of it. So I'm going to do one at a time. I've got this blue one in here. So where's a pink? Well, this pink is here. So if I move it from this perspective, I'm going to move this whole thing. I don't want to do that. So what I think I might have to do first is, because these centers move along with this, is I may want to put these in place before I put anything else. So does this actually belong here? Well, this is brown, so I'm going to say it belongs over here. So I'm going to move this in like so. Now I'm going to move this back without moving this one out, and I think I can do that. Well, the only way to do that is I have to 3-cycle. So this is where down, down, up, up is going to come in. So I think if this is out, necessarily these two must also be out. So I'm just going to focus on this and go up, up, down, down. Now I haven't solved this yet, so I'm kind of figuring out as I go. Now here's my suspicion. This is now in. You can see these colors match. Based on the parity of this puzzle, if this is in, these two have to be in as well. When I say parity of the puzzle, I mean the inherent structure of this, being odd or being even. Now usually when we think of the word parity, we think of it as kind of a negative thing. That something has to do like an impossible looking flip. But parity can actually work for you when it comes to puzzle solving, because if the structure doesn't break parity as you scramble it, then it means that there's a consistency with how these pieces are related to each other. So I know that these two can't flip-flop, so they must be correct, and as I turn it around, I see that this is right and this is right, so by necessity this is also right. So I've got these centers in. How about over here? Well, this one isn't in, and it's going to be scrambling with these. So I don't even have to pay close attention to what's going on. I know this is wrong, so I'll just go up, up, down, down, and the parity of the puzzle will guide me the rest of the way. Is this correct? Nope. So we do it again. Up, up, down, down, and so now we're good. This is in and this is in. The parity of the puzzle dictates this must be in as well. And sure enough it is. And this is also in over here. Okay, so this was placed in much like a floppy. These are placed based on down, down, up, up with each side here. So now we're going to put in these edges. This one is already manufactured, so this is already magically in. This is well in the way of being completely solved, so maybe my scramble isn't all that great. But let's say I want to get corners in with this. Now, if I have my edges in here, I might as well put edges in with all of these guys too, or maybe not. So what's the best way of doing this? I've got these in here. I want to move corners in. This corner is where it needs to be, so that's fine. What about anything else? Is anything else here that belongs? This guy I want to move to here. Well, I know that I can move this in by doing that algorithm. And that's that corner swapping algorithm, which will move this to here. Well, actually, this will go here, this will go here, and this will go here. So keep doing that until this ends up here. To our U, to our UI, to our turn, turn, to our UI, to our U, and to R. So the good thing about this is I have not had to figure out any new algorithms to move this back. One more should move this into here, to our U, to our UI, to R. Now I don't want to challenge the puzzle too much. It snags a little bit, and I just don't want to have pieces pop out just when I'm about to do a move. To our UI, to our U, and to R. Okay, that worked pretty well because all of these were where they needed to be. They just had to be rotated around. So this is done. This one looks like it is really close to being completely done. So here's the blue one over here. I guess I can work on this one. So I want to move this blue to here. And actually, before I do that, why don't I move these guys in to where it's supposed to be over here, and then move it in over here. Silver and dark blue, silver and dark blue. So what I'm going to do is keep this here, and I'm going to rotate it until all of these guys are in. Actually, yeah, okay. So it doesn't matter exactly where, but what I want to do is get these two over here. So holding this over here, this guy will end up here. To our U, to our UI, to our UI D, to our UI, to our U, and to R. Okay, that worked. That's in here. Now I'm going to hold this to the right and keep doing that until this guy finds its way to here. To our U, to our UI, to our UI D, to our UI, to our U, and to R. Okay, this one didn't get destroyed, as I knew it wouldn't. So I've got these three in. I've got to move it to here. So how am I going to do that? Well, from this angle it can move in. So let's see. If I move it like this, all of these come in. So I'm going to take this whole middle part, move it to here, double turn this so that this can now move, and I'll move it back. And lo and behold, now this is it. Now granted, the first two generally tend to be easy, but let's see where things go with the rest of them. Anything else? Why don't we work on this guy? This looks like everything's in, just the whole thing is rotated wrong. So, yeah. Now this is where I might have made a little bit of a mistake, because these all have to be rotated, but I've already put these in. So I need to rotate these guys without disrupting what I did over here. So how am I going to do that? Well, I could move this down here, double turn, and move this back. So now this is lined up over here. This is still in configuration, and so is this. So I haven't really messed that up. But what I can do now is take this and move this in conjunction with these guys here. So double turn. Well, I'm going to end up putting it on the wrong side. So I can, no. Here I'll have to move it like this. Let's see, I'm trying to see how I can do this. Yeah, I think I might have to go back to the drawing board a little bit and put all these edges in before I put these in. So what I'm going to do is I'm going to have to, I'll keep this fine, but I'm going to have to mess this one up because I made a little bit of a mistake putting all of this in. So what that means is I'm going to move this in so that these are lined up, turn it like so, and then move it back. Alright, so these two are in. I still haven't disrupted this, so all hope is not lost. And now what I've got to do is I'm going to take this move this to the pink, then double turn it, and then take all of this where these are all in and move it back. Now, I somehow managed to keep this from being destroyed, and to be honest with you, it was all fairly intuitive, but just moving that around, I managed to put these guys in. Now, how am I going to move these? Well, all these corners are where they need to be, they just have to be rotated correctly. So I'm going to start moving them around. So this is going to come to here, to our U, to our UI, to our UI D, to our UI, to our U, to R. Okay, this is turned back, and notice we now have this one in, so I'm going to keep this here. This shall move this over to here, and these guys will move here, and this should be in. To our U, to our UI, to R, turn this one if I can, snagging a little bit, UI D, to our UI. So I'll tell you, it is a stable puzzle. Sometimes it feels like pieces want to come out, but David really designed this very well. And turn. Okay, so that's it. So far the solve is fairly straightforward, no real tricks. So these are all in. Now I've got to get these, and I think this is going to be a little bit more difficult. So what I'm going to do is I'm going to get all the edges in first before I do the corners. I think I kind of got a little bit lucky with these. So where's the pink one? Well, here's a pink. So what I'm going to do is take this, move this in, bring it out here, move this back. So I've actually got these two in, and these corners are where they need to be as well. Okay, now what else do we have? This brown one has to come in. So the way this is going to work is I'm going to take this, move this to the brown one, move it out, and bring it back. Okay, now I have to find the turquoise, which is right here. So how am I going to move this in? Well, it should be just a simple matter of I'm going to move this to here, turn it around, then move it back. So this turquoise will move in. I'm going to double turn it, move it back. So now all these guys are in over here. Now so that I don't run into any trouble, I'm going to move these centers in as well. Or I guess edges, not centers. So where's the orange? The orange is right here. 1, 2. Move this in. Now what's waiting here is white, so if I move it to this direction, this white will meet it. Move it in here, and the white indeed meets it. So now I need the red, which is right here. Put this into position. move the red in, and now turn this to where the green is so that this lime green can meet this over here and turn. So now all these are in. The only problem is that these aren't. So I've got this one in, but these aren't here. And the parity of the puzzle is still guiding me because I've got a potential 3 cycle. It's going to be hard to coordinate a 3 cycle, so what I'm going to do is I'm just going to start moving things around. So I'm going to move this down, bump this out of the way temporarily, move this in place, and then move this back. So I've got this lined up with the purple and this one lined up with the green. I took one of these out, but that's okay. I'm about to put it back in as I 3 cycle these two with this. Now when I say 3 cycle, I don't have an algorithm that I've designed. All I'm going to do is take this yellow, line it up with this. Okay, now that this is lined up, the green one is the odd one out. Line this up over here, so this silver one, or gray, or however you call it, will match with this, and this green will end up with this green, and kersplat. Alright, so what I've done is all these edges are lined up, and all these edges are lined up, as are these. So now it's a question of putting corners in. So I have to coordinate all these corners together. Well, I kind of like this one where it is. Do we have another pink? And I don't. How about a blue? I don't have that either. So that's hanging out over here, and here's the pink over here. So I'm going to make use of the fact that this algorithm does not affect anything. If I were to apply the algorithm here, does not affect anything here, does not affect any of the edges here, and only affects 3 of the corners. So what I can do is maybe take this, and I'd like to get this pink into this position. So what that means is I'm going to take this out of the way here, and I want the pink in this position. I'm just going to move this up, and I'll do the algorithm until this pink is over here, and then move it back down. I'm not going to affect any of the edges, so that won't be affected by what I'm doing. So 2R U, 2R UI, 2R UI D, 2R UI, 2R U, 2R, and this turns back. Okay, so you can see that this didn't make it to here, so all I've got to do now is turn this back down, see if it worked, kersplat. So yes, this is all in over here. So, doing well. Yeah, okay. So now I need to do a blue one or a brown one. Do I see one here? I don't, so it must be here somewhere. Let's line this up correctly. So I want to get this brown to here. So I'm going to take this and move it up. Get this brown out of the way, move it to the side here, because I want to move the brown one to here. So I even know the positioning now, so holding it here, this will end up here, all the rest will be the same. These will all cycle around. 2R U, 2R UI, 2R. So I'm using the known parity of the puzzle as well as how these algorithms affect which positions 2R. So no problems. Move this into place over here. Rotate this back. And kersplat. So we've got this one in. Now I got to find the turquoise and blue, which is right over here. Bump this to the side. Take this. Move this up here. None of these edges will be affected, but this will end up here. 2R U, 2R UI, 2R. So far this puzzle is being solved purely by one algorithm. It's a one algorithm puzzle, which is one of my favorite kinds of puzzles. Because I don't like to memorize stuff, I just like to solve. Bring this back over here. And kersplat. Okay, so now this is solved. Made short work of that one. So now we've got these two. So the question is, do we have everything that we need on one side? Well, I like this here. This orange wants to move over here. Well, that's not going to be difficult. All I got to do is hold this here. This won't change, but I'm going to keep doing that until, well, actually, this orange has to come here. Is that orange? Yeah. Yeah, orange and green. So do it once, and this should end up here. 2R U, 2R, UI, 2R, turn, turn, 2R, UI, 2R, U, and 2R. So this is in, so we're good. And now we've got one more that goes into here, and it's, well, where is it? It's up here somewhere. So this needs to come into here. So I already know I'm going to position this to here. I'm going to take the blank one, move this like so, and move this up. This that got dragged here will not be affected. This will just move here. 2R, U, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, 2R. We like this over here. Move it in position. Move this in position and bring this all down. So now we're good over here. So all we have left is this one, but we don't have to borrow from any other sides. Everything is in where it needs to be. So one turn of the algorithm should move this to here, this to here, this to here, and it should be done. 2R, U, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, and finally one more slice like that, and it's good. Move this in position, and the puzzle is solved. Actually, move this in position here. We're good? We're good. Okay, so there it is. The Star of David, entertaining puzzle. It's really just a one algorithm puzzle, which is fine, but in that one algorithm we're able to place pretty much everything that we want. It's just a question of positioning and repositioning. So fun puzzle, good job David. And now we're going to go to some other puzzles that might have a little bit more complexity in terms of the number of algorithms that are needed.